Welcome to this video. We're going to be talking about the definition of a function. So before we talk about functions, we need to talk about something called relations. So relation is a set of ordered pairs. It's just a matching of items, numbers, quantities, or really anything else that has a relationship between those two things. And the question you're always asking is, if I know one quantity, can I then determine the other? Let's look at some examples. So relation could be a set of ordered pairs like this one, 3, 2, 3, 5, 4, 1, 4, 2, and these numbers are matched, so that's why they form a relation. Or it could be items like countries and brands of chocolate. Telling you the country, can I then know what type of chocolate they make or what brand of chocolate? Or it could even be the position of an ant over time as it walks on a piece of paper. So any of these are examples of relations. Now there's a special type of relation that we call a function. So functions are relations such that the input values have unique output values. So what's an example of that? Well, think of age and height. Height is a function of age because your age uniquely determines your height. It's not possible for you to be two different heights at the same age. So for example, if I said, how tall were you at 15 years old? Well, there's only one answer, 45 inches. But the reverse is not true. Age is not a function of height because it is possible for you to be the same height at different ages. So if I said, how old were you when you were 72 inches tall? Well, I was that tall at 20, 21, and 22 years old, so there's no unique answer. Now, sometimes the relationship between the input value and the output value follows a pattern, and we can model this pattern using a formula. So for example, let's say every year of your life, starting at age 5, where you were 40 inches, you grew 3 more inches. You can model this with an equation. So we'd say height is a function of age, such that your height is going to be 3 times your age plus 40, because 40 is what you started at. Now there's an easy way we can tell if a relation is a function by looking at the graph. We call this the vertical line test. Are there any points on the graph where you could draw a vertical line and it would cross twice? If that's true, then the relation is not a function. So in this one, we draw a vertical line anywhere. It's only ever going to cross once, so this is a function. On this next one, if we draw a vertical line right here, boom, it hits twice, so this is not a function. On this last one, again, anywhere we draw a vertical line, it's only ever going to hit it once, so this is a function. Within the functions, there's an even more special category called one-to-one functions. So relations are known as one-to-one functions if the input and output values can be switched and the relation is still a function. For example, circumference and radius of a circle. If I tell you the circumference of a circle, then you can for sure tell me the radius. And vice versa, if I tell you the radius, you can for sure tell me the circumference. So that is a one-to-one function. But a non-example would be like height and age. If you tell me your age, I can for sure tell you how tall you were at that age. But if you give me a height, I don't know which age you were because you were more than likely the same height at different ages. So just like the vertical line test, we can do another test called the horizontal line test to determine if a function is one-to-one. And it's the same idea. If we draw a horizontal line going left to right and it crosses anywhere twice, then we know it's not one-to-one. So like, look at this. This is definitely a function because it passes a vertical line test, but it does not pass the horizontal line test. Right here, it crosses twice. So we know this is not a one-to-one function, but it is a function. Let's try some practice examples. For each set of ordered pairs below, determine whether it is a function and if it is one-to-one. So to do it with ordered pairs, we start with the x values. 0, 5, 8, 6, and 6. We have 2 repeats here. We're looking for repeats. Now, do those repeats have the same y value? No, this 6 has a 4 and this one has a 0. Therefore, we have an input value which is not uniquely determining an output value. So if I give you 6, I don't know, is the answer going to be 4 or is it going to be 0? So this is not a function. It's a relation, but not a function. What about this next one? Starting with x, 8, 3, 9, 6, 7, no repeats, so we're good, it is a function. Now the question is it one-to-one? To do that, to determine that, we have to look at the y values. 0, 9, 9, okay, we got 2 repeats here, 7 and 1. So on these repeats, we notice that the input value is different, but the output value is the same, so this is not one-to-one. It would only be one-to-one if we had no repeats. in the x's or any repeats in the y's. So let's try a vertical and horizontal line test. Does the graph below show a function, and if so, is it one-to-one? Vertical line test, yes, it's a function. Horizontal line test tells us no, it is not one-to-one. The next one, yes, it is a function, passes the horizontal line test, and it also passes the, passes vertical line test and the horizontal line test. So this is a one-to-one function. How we spell that wrong? One-to-one function. Which of the following equations is a function? To solve this, we don't have a graph, so let's just graph this expression right into the Desmos calculator. It graphs this for us, and we get the following. Obviously, this does not pass the vertical line test. We've got two intersections here, so that first one does not form a function. We can cross it off. The next one, putting it right into the Desmos calculator, we get this. Again, this does not pass a vertical line test, so that one is not a function either. On the next one, x equals -7 is just a vertical line. Obviously, a vertical line is not going to pass the vertical line test, so that neither is a function. Our last one is a line, x equals 6y minus 1. This does pass the vertical line test everywhere you go, so this is a function. And just a note, if you ever see a y squared, more than likely it's not a function. And if you ever see a x equals some constant, it's also more than likely not a function. So you can use those two hints to help you out. All right, and that's it for this lesson, so go ahead now and try some practice on your own.